Okay, I think we're going to get going now. So I'd like to start by saying hello to everyone. Thank you so much for joining us for this webinar today. My name is Mandi Wise, and I'm a solutions architect at Apollo. And that means that I spend a good portion of my time helping our enterprise customers migrate to and get up and running with Apollo Federation. And a good portion of that work has to do with schema design. So today, I'm really excited to have the chance to talk to you about some schema design best practices to keep in mind when you're adopting a federated data graph. Now, before we jump into the content, we have a few housekeeping items. So the first is about the Q&A portion of today's session. If you have questions along the way, then you can drop them in the Q&A box in Zoom, and we'll save some time at the end to answer as many of the questions as we can. And in terms of what questions would be best suited for this webinar format, it would be best to stick to general questions about federated schema design, and especially in relation to the best practices that we're going to talk about today, rather than super specific questions about your schema or your specific architecture or any really specific debugging questions. So if you need to drop a code snippet into the Q&A to ask your question or provide extensive architectural details for context, then I would encourage you to instead post those questions on Apollo's new forum at community.apollographql.com, because that's probably going to be a much better medium for having those kinds of in-depth discussions. The second housekeeping item is that we'd really appreciate your feedback after the session, and we'd like to know what topics you're interested in for future sessions as well. So please take a few moments to fill out the post-event survey if you can. And lastly, we have a product update event coming up on June 24th. So if you'd like to know more about all of the exciting things in store for Apollo Federation, then you can use the link that we drop into the chat to sign up for that event as well. Okay, onward to schema design best practices. The best practices that we'll discuss today have been organized into several high-level categories, and some of the best practices are federation specific, and some are applicable to both federated and non-federated GraphQL APIs. And I think it's always helpful to have a refresher on these. And they're certainly open for adoption of Apollo Federation for our enterprise customers. Okay, so for our first best practice, the first step toward designing a federated GraphQL API is to start thinking in entities. And before exploring this best practice in depth, I'd like to do some quick level setting around how Apollo Federation works at a high level. And to do that, I'd love to know more about who here today is currently using or considering federation. So let's do a quick poll. So we've got some options here for whether you're using federation with managed federation, without managed federation, or no. We'll give everyone a few more seconds to answer the poll. We should have results shortly. Okay, so the results are in, and we have 32% of the participants today are using managed federation, 16% are not, and it looks like we have 52% who are new to federation. Okay, cool. That is definitely useful context for me to have as we move forward. And so the slides that follow here are going to be really helpful, especially for those who are newer to Federation. So if you're newer to how Apollo Federation works, let's do a quick overview of some key concepts. So Federation allows teams to embrace separation of concerns so that they can work on different products and features that are powered by a single data graph, and they can do this work without stepping on each other's toes. And splitting subgraphs by concern is key here because it differs from other approaches to designing distributed GraphQL architectures where the boundaries between your different subgraphs are often delineated explicitly by types in the schema. And on top of that, an Apollo gateway takes a declarative approach to composing your subgraphs together, and it handles query planning for you. So you don't have to deal with the imperative pain points of other approaches to GraphQL consolidation. So that means that backend teams can independently manage their portions of the data graph while still exposing a single GraphQL endpoint to client developers. So with this kind of distributed GraphQL architecture in mind, one of the most important concepts in federation is that of an entity. And in Apollo Federation, an entity is an object or an interface type that you define canonically in one subgraph, and then you reference and extend in other subgraphs. So by serving as extension points between your subgraphs, these entities end up acting as the building blocks of your federated data graph and are ultimately what allow you to separate your subgraphs by concern instead of type. So how do we make an entity? Well, designating any object type as an entity is as easy as adding the atkey directive to its definition in the subgraph schema. And the atkey directive that we see here defines the entity's primary key, which consists of one or more of the types fields that can uniquely identify the object that it represents. And in this example here, we can see that the product entity's primary key would be its UPC field. So in other words, setting the UPC field as the key means that other subgraphs that want to use this entity will need to know at least that value for any product. So when used in other subgraphs, you can think of the UPC as acting like a foreign key. So the Apollo Gateway's query planner can use the entity's key to identify a given instance of the type. And ideally, the keys that we define are in fact values that uniquely identify a resource. So in other words, we want to avoid scenarios where they are used to arbitrarily pass around dynamic field data through query execution between your subgraphs. So once you define an entity in a subgraph, that's where things start to get really interesting with federation. So after you define an entity in one subgraph, other subgraphs can then reference that entity. So in practice, that means that once the product subgraph defines the product entity, a review subgraph can then add a product field with a return type of product to its review type, as we see here. And because the product entity is defined in another subgraph, the review subgraph needs to define a stub of that type to make its own schema valid. And the stub includes just enough information for the service to know how to interact with a product. And in our case, again, it's that UPC key field. And note that the UPC field must be annotated with Federation's @external directive here to indicate that the field originates in another service. And also note that because we want to use spec-compliant GraphQL, we're going to use the extend keyword here to indicate that the product type is an object type that's already defined in another subgraph. And we aren't limited to simply referencing the product entity in the review subgraph either. So we can also extend an entity with additional fields that are defined by the review subgraph itself. And when a service extends an entity, the entity's originating subgraph is not aware of the added fields. Only the extending subgraph and the gateway will know about these fields. So let's say that we want to add a reviews field to the product entity that will hold a list of reviews for the product. The product entity, as we've seen, originates in the product subgraph, but it makes much more sense for the review service to resolve the reviews field for a product because it actually has direct access to this data. So to handle this case, we can extend the product entity in the reviews subgraph as we see here. And for the new reviews field, note that we don't include an @external directive on it because this field actually does originate in the reviews subgraph in this case. So through this process of entity definition and referencing and extension, we can see one of Apollo Federation's superpowers and how it enables us to split a GraphQL schema based on that more logical separation of concern. And it gives developers an intuitive way to interact types that are defined in other subgraphs. So when you're embarking on a new federation project or you're adding new subgraphs to an existing federated data graph, it's important to evaluate what types exist in your graph that suggest that they will naturally play this entity role. And entities also help us make decisions about where subgraph boundaries may be drawn as well. And if your spidey senses are up now and you find yourself wondering how do decoupled teams reference entities that are owned in other teams' subgraphs and in a way that doesn't break down into a completely chaotic free-for-all of breaking changes, then I have an answer for that. And that answer is to use a schema registry such as Apollo Studio that will help you sleep at night knowing that one team's proposed changes to the data graph won't break composition for everyone else. So in other words, it's going to put some guardrails in place around how data is going to process across your teams. Now, before we jump into the remaining best practices, I'd love to know a little bit more about what's motivated your interest in federation. So let's do one more poll. Okay, so the question is, what motivated your interest in adopting Apollo Federation? And you may be coming from a background of having a monolithic GraphQL API that's challenging to iterate. You may be replacing a BFF strategy. You may be consolidating multiple existing GraphQL APIs into one. Perhaps you're starting greenfield with a federated GraphQL API in front of your microservice architecture or something else, or you're not quite ready to adopt Apollo Federation yet. So we'll just give a few more moments for people to respond, and then we can take a quick peek at the results. Those results should be coming in shortly. Okay, and they're in. So it looks like we've got a pretty good split here. People coming from monoliths, some from BFFs, definitely a few people coming from having multiple GraphQL APIs and wanting to tame that beast with some GraphQL consolidation driven by federation. And also quite a few people here who are starting greenfield as well. So that's great. This is a really good distribution and very much reflective of what we see with our enterprise customers as well. Okay, so whatever your reason for considering Apollo Federation and feeling the need that it's time to do some GraphQL consolidation, when companies decide to consolidate their data graph, from what I've seen, this move is often motivated in part by a desire to simplify how clients access the data they need from a GraphQL API that's backed by a distributed service architecture. So they may be coming from a world where they had backends for front ends or multiple GraphQL APIs in use, as we've seen, and they want to consolidate and streamline their APIs behind a single endpoint for clients, but without introducing the bottleneck or constraints of a traditional monolithic GraphQL API. So with that client focus, when designing and evolving schemas for federated data graphs, we want to make sure that we're keeping in mind the kinds of product experiences we're trying to drive via the graph, as well as how to best support client developers who will bring those experiences to life for end users. So when migrating to Apollo Federation, it's often the case that there are more than one client applications consuming any non-federated GraphQL APIs that the company has already developed and put into production. So if you already have measures in place to collaborate with client teams on schema evolution, then that's amazing. But if not, have no fear, this would be a really great time to adopt that practice. So in general, client teams should be consulted early in the schema design process, as well as on an ongoing basis. And client teams should really just drive these discussions wherever possible. So rather than simply asking for feedback from client developers, ask them to explain what data they need to render a particular view in their application and what the ideal shape of that data would be. And it's then the job of the schema designers and owners to aggregate this feedback across the different client teams and reconcile it against the broader experiences you want to drive via your data graph, as well as, of course, what's technically possible in relation to your backing data sources and the schema governance measures that your company has in place. And as you're working on your schema, be sure to take advantage of the fact that federation allows you to design your schema in a way that expresses the natural relationships between the types in your graph. So for example, without federation, you may have seen foreign key-like fields as being a requirement for a subgraph schema to join the nodes of a data graph when those subgraphs are split by type alone. But with federation, as we've seen, our view subgraph can represent a truer subset of the complete data graph by using those entity references and extensions that we explored. Now, onto our third best practice. This is very much related to the practice of demand-oriented schema design. And there's a really strong imperative as a schema design best practice with GraphQL to prioritize the expressiveness of your schema. And by this, I mean that a good GraphQL schema will convey meaning about the underlying nodes in your data graph, as well as the relationships between those nodes. And there are many dimensions to schema expressiveness. And I would say in many ways, it underpins most of the best practices that we're talking about here. But I'm going to focus on some very specific tactical concerns in relation to how you write your schema. So being consistent about how you name things may go without saying, but it's even more important when composing schemas from multiple subgraphs into a single federated GraphQL API. So for example, mismatches between field naming approaches from different subgraphs won't provide a very consistent or intuitive experience for clients. And the outset of a migration project to a federated data graph is a good time to take stock of what naming conventions are currently used in your existing GraphQL schemas within your company, and then determine what conventions will become standardized, and then onboard subgraph teams to those conventions and plan for field deprecations as needed. And good schema governance practices are really key here to maintaining schema expressiveness as more and more teams are onboarded to the graph and more teams begin consuming the graph. Okay, so as we've discussed, a GraphQL schema should be designed around product requirements. And ideally, the fields that are added to your schema to support those requirements will be single purpose. So in practice, this means having more specific, finer grained mutations and queries, and of course, also having guidelines and trainings in place for API contributors to understand how to design these kinds of fields for their subgraphs. So as an example, this query would create ambiguity for clients about what would happen if neither the ID or the username arguments were submitted with this query. Because if we want this query to be general purpose, to fetch a user by either argument, then we can't make any of those arguments non-null if we want it to remain generic. So having two different queries with non-nullable arguments would provide a more predictable experience for clients. And this finer grained approach also applies to mutations. So rather than having a single update account mutation to rule them all, we can instead implement more purpose-built mutations when these values are updated independently by clients. And one caveat here is that if any of the values needed to be updated simultaneously or not at all, then it would make more sense to bundle these updates into a coarser grain mutation. But apart from this, opting for finer grain mutations helps us avoid the same pitfalls as finer grained queries do. And it saves you from having to do extra validation work at runtime to determine that the submitted arguments in the operation will actually lead to a logical outcome for the mutation. Okay, so as my last tactical point around schema expressiveness, this is something that I often see as a backlog item, but prioritizing it can go a long way in empowering client developers to understand the intentions and the full potential of the fields added to a schema. And this is to add documentation to your various schema components. And the imperative to better express the intentions of your schema through documentation is codified in the GraphQL specification itself. And the spec states that documentation is a first-class feature of GraphQL type systems. And it goes further to say that all types, fields, and arguments and other definitions that can be described should have a description included with them, unless they're entirely self-descriptive. So just as with naming conventions, I would say it's important to establish standards for documentation across a federated data graph from its inception to ensure consistency for API consumers. And again, having governance measures in place to support these documentation standards is also a really good idea. Okay, so for our fourth best practice, we're going to move on to the topic of nullability. And this is an interesting one because depending on what parts of a schema we're talking about, non-null fields can help us guard against breaking changes in some instances, but can also increase the likelihood of breaking changes in the future for other cases. And as always, with federation, we want to think about what the ramifications of these nullability related decisions are, because they can become slightly more complex when we're thinking about them on a distributed scale. So it's a fact that non-null fields can make results more predictable for clients, but they have the trade-off that including them, whether it's a field or an argument, as non-null in your schema, can make that schema harder to evolve in the future. So as an example, if a non-null email field on a user type is converted to a nullable field, will the clients that use that field be prepared to handle that potentially null value once that update has been made to the schema? And conversely, if the schema changes in a way that a client is suddenly expected to send a previously nullable argument with an operation, then this may also result in a breaking change for them if they're not prepared to do so. So we can see how it's important to make informed decisions about nullability when initially designing a subgraph schema. But you're inevitably going to be faced with making a breaking change of this nature as your schema evolves. But that's okay. No need to despair, because when that happens, your GraphQL observability tools, such as Apollo Studio, give you insight into how those fields are currently used in different operations and across different clients, so you can make these updates in a safe and informed way. And another important consideration is how non-null arguments and input fields on mutations can help you avoid breaking change scenarios in the future too. However, this is typically going to require that you design finer grained mutations and avoid using those everything but the kitchen sink style inputs as arguments that are filled with all kinds of different nullable fields to account for all possible use cases. But as a bonus, when you use those finer grained mutations, as we've discussed, this helps make your schema more expressive and more predictable and understandable for clients. Now, when adding fields to a schema that are resolved with data from third-party data sources, the conventional advice is to make these fields nullable given the potential for a request to fail or for the data source to make breaking changes without warning. And a federated data graph adds an interesting dimension to these considerations, given that many of the entities in the graph may be backed by data sources that are not immediately adjacent to a subgraph service or within their direct sphere of control. So the matter of whether you should make referenced entities nullable in a subgraph schema will depend on your company's existing architecture, as well as its internal SLAs, and is likely going to need to be addressed on a case-by-case basis. Okay, so on to best practice number 5, which is about abstract types. And the GraphQL spec currently offers 2 different abstract types in its type system, and those are interfaces and unions. And interfaces and unions are really powerful tools to express relationships between the types in a schema. But when you're adding these types to a schema, and especially a federated schema, it's important to do so with a clear-eyed understanding of the longer-term implications of managing these types. So a common misuse of interfaces that I see all the time is to use them simply to express a contract for shared fields between types, and that's all. So ultimately, they should be reserved for when you need to return an object or a set of objects from a field. And those objects may represent a variety of different types with some fields in common. And this is my #1 pro tip for interface usage in any kind of GraphQL schema, whether it's federated or not. And that tip is going to be is if that interface isn't being used as an output type anywhere in your schema, then there's a good chance that you don't need it. So for example, in this schema, the family pets query returns a list of cats and dogs with a guarantee that the breed field will be implemented on both the cat and dog types. And a client can then query these types shared fields as usual, or they can use inline fragments for the cat and dog types to fetch their type-specific fields. And if there was no use case for ever querying both cats and dogs simultaneously to return both types from a single operation like this, then the pet interface wouldn't serve any notable purpose in this schema. Instead, it's just going to add overhead to your schema maintenance by requiring that the cat and dog types continue to adhere to this interface as they evolve, but with no functional reason as to why they should continue conforming to pet. So building on this, interfaces and unions should be added to a schema and subsequently evolved with careful consideration because subtle breaking changes can occur for API consumers that rely on them. And again, this is important for non-federated APIs, but even more important with federation because of the complexity that you can introduce when related concrete types cross subgraph boundaries. So for example, a new goldfish type may implement the pet interface in a later iteration of your schema. And the previous get family pet operation may now return results that include goldfish, but the client's user interface may have only been tailored to handle results for cats and dogs. So without a new inline fragment in the operation document to handle the goldfish type, there would be no way to retrieve its lifespan field value. And this may be really important information as far as the client user interface is concerned. So as we can see, it's important to communicate these changes to client developers in advance. And it's also incumbent on client developers to treat fields that return abstract types with extra care to guard against these kinds of potential breaking changes. So as a final consideration when using abstract types with federation, this can be a little bit of a tricky matter to resolve when they're reused across different subgraphs in your schema. And long story short, the resolve type resolver will need to be able to resolve all concrete types for a given abstract type within the context of a single subgraph. So this is important to keep in mind when designing your schema if you have some complex use cases for interfaces and unions in mind. All right, so for our sixth best practice, we want to think about what process we'll use to safely retire fields from a federated data graph once they're no longer needed or supported. And your current strategy for this may be to never actually remove any deprecated fields because you're not sure when it would be safe to do so, which may be sustainable for a while, but over the longer term, it's going to create a lot of noise in your graph. So as a remedy, your internal schema governance group should outline a company-wide field rollover strategy to gracefully handle type and field deprecations throughout the unified graph. And doing so is going to require clear communication with API consumers, as well as visibility on how they're querying your graph. So as a first step, the @deprecated directive, which is defined in the GraphQL specification, should be applied when deprecating fields or enum values in your schema. And the directive's single reason argument can also provide the API consumer some direction about what they should do instead of using that deprecated field or enum value. And I should also mention that the @deprecated directive is fully supported by your Apollo server-based subgraphs. So you can use it just as you would for a non-federated GraphQL API that you build with Apollo server. Now, just as an example to illustrate that point, here we can see that we indicate that a top products query has been deprecated in favor of a products query, and we do give the developer a little bit of extra information about what they should use instead of that top products query in the reason argument for the directive. Now, after a subgraph schema has been updated with new deprecated directives, it's important to communicate the deprecations beyond the SDL as well. And having a dedicated Slack channel or a channel in Microsoft Teams or space in a team meeting may serve as an appropriate communication channel for relaying these notices. And when you share this information, you should also share some information about additional migration instructions that are going to be beneficial for client developers. But even after all this asynchronous and synchronous communication, there's still an important question that remains, which is when will it be safe to remove the deprecated fields from the subgraph? And to answer that question with any certainty that you won't cause breaking changes to client applications, you're going to want to lean on your observability tooling again. And specifically, we can see some operation tracing data from Apollo Studio here and how it can provide you with insight into what clients may still be using in terms of the operations they're running that may include deprecated fields. So you can action appropriate follow-ups as needed, and you'll know when it's safe and it's a good time to actually remove that field. Okay, so on to our seventh and final best practice for today. We're going to talk a little bit about cross-cutting concerns when we're dealing with federation. And there's a very good question we might ask here, which is what kind of cross-cutting concerns are we talking about? So sometimes with a federated GraphQL API, subgraphs may need to share ownership of certain types rather than assigning that type to a particular subgraph. And we may need to do that for cases where we want to have identical object types across graphs for pagination fields. So to illustrate this example here, if you're implementing relay style pagination, you'll need to have a page info object for each of the subgraphs where you apply pagination fields based on that relay spec. And luckily, we can share object types like this across subgraphs with Apollo Federation. And we can also share scalars, interfaces, enums, and inputs too. And when we do that, we call these things value types. And there are nuanced differences in how these value types may actually be shared across subgraph schemas. And you can head over to the Apollo Federation docs for more information about all of the different criteria you want to consider for each type of type when you're sharing them. But as a general rule, where subgraphs share value types, then those types must be identical in name and contents. Otherwise, errors will occur. And it's a good idea to make sure that their behavior is logically consistent as well across the subgraphs where they're defined and resolved. And there's no way for us to test through composition for logical consistency of these value types implementations. But for the sanity of your client developers, this is something that you're going to want to make sure you're taking care of on your end. And based on these criteria, I think that the page info type here is ultimately a really good example of something that should be a shared value type, because it's not something that's going to change very often, if ever. And this also doesn't represent a uniquely identifiable resource that needs to be owned by one subgraph and then potentially referenced elsewhere, because in that case, it should really just be an entity. So custom directives may also be shared. And when we're talking about sharing custom directives, we need to think about the two different kinds of directives that we're dealing with. So first is type system or schema directives. And these are the directives that you use to annotate your schema. And these kinds of directives may be handled on a service by service basis because they're stripped from the gateway schema. Executable directives, on the other hand, or you may also refer to them as query directives, are those directives that we use to annotate our operations. So a good example of this would be the built-in @skip or @include directives. And these directives must be defined in the schemas of all subgraphs in your federated data graph and with the same locations, arguments, and argument types. Otherwise, composition errors will occur. And further, and similar to the value types that we just discussed, all subgraphs should use the same logic to handling executable directives as well, so that you can avoid any ambiguity for clients that are applying those directives to their operations. So what does all of this mean in terms of deployment? Well, it means that if you change a value type definition or an executable directive definition, you're going to need to make that change simultaneously across the subgraphs that define those schema components. So you'll want to carefully evaluate the potential long-term impact and complexity of introducing any cross-cutting concerns into your federated GraphQL API. And there may be some different approaches to handling type ownership and directive ownership in the future with federation. So I would encourage you to stay tuned to future product updates and webinars for info as that becomes available. But for now, you want to have a plan for how to handle these changes as they arise, and perhaps opt not to use shared value types when you're dealing with a type that needs to be updated at a high velocity, or perhaps at different velocities across different subgraphs. Because in those cases, something like subgraph level namespacing may be better. Or again, in some instances, it might actually make more sense to make a particular type an entity if it's an object or an interface. Okay, so summing up, I'd like to tie together some of the key themes that have emerged across the best practices that we've explored today. So as we've seen today, virtually all general GraphQL schema design best practices apply to federated data graphs too, but you just have to think about them on a larger and more distributed and potentially more complex scale. The second key point is that governance standards and the way you enforce those standards is key to ensuring that entropy doesn't have its way with your schema over time, and that you continue to evolve your schema in a way that enhances usability and predictability for client developers. Third, communication between subgraph teams and with client teams is also so important as a schema evolves. So having automated ways to do this through a schema registry and Slack or Teams notifications is a must, but also having dedicated space for synchronous team communication about schema updates is also really important too. And lastly, as subgraph owners propose schema changes, a schema registry and your observability tooling, such as Apollo Studio, can give you immediate insight into whether those changes can be done safely and not cause breaking changes for other subgraphs or for client applications that are currently running operations against the graph in production environments. Okay, so if you have enjoyed the content in this webinar today, I'd encourage you to take a look at our GraphQL at Enterprise Scale guide. It's a PDF that you can download for free. And chapter 4 of that guide currently contains a good portion of the content that we've covered today and is specifically focused on the topic of schema design best practices in Federation as well. And with that, I'd be happy to take some questions now. I'm just going to stop my screen share. Just take me a moment. And then I can jump into the Q&A box here. And just as a reminder, we're going to try to focus the questions as much as on the webinar content as possible, and probably keep it pretty high level. So if I don't get to your question because it's perhaps maybe a little bit too specific for this, this context, again, I'd encourage you to head over to community.apollographql.com, and you can post your specific schema design question with code snippets and any additional architectural details you need to provide there. So jump into the Q&A. And let's see. If I start today without Apollo Federation with a unique schema, is it possible and easy to break into federated schemas afterwards? So this question is from Paulo. So to answer your question, I'd say yes. I mean, there's always going to be a migration process involved, but if you have the intention to move towards federation from a monolithic GraphQL API down the road, you can certainly do so with some of the schema design best practices that I've mentioned in mind. In terms of, especially like things you might want to think about are nullability and how you're implementing abstract types throughout your schema. You may even have it on your radar which types in your monolithic GraphQL API may lend themselves to becoming entities as well in the future. So yes, 100%. This is a very common path that we see with our enterprise customers where they're taking that monolithic GraphQL API and they want to start federating it. And a really common approach that we see in doing that is to take a strangler fig approach where you start with your monolithic GraphQL API and you begin breaking off subgraphs one at a time. So rather than trying to approach it as some kind of big bang rewrite, you maybe break off your first subgraph service that corresponds to some microservice or cluster of microservices where you want to manage that schema a little bit closer to it. You just do that one at a time. Your monolithic GraphQL API effectively acts as your first subgraph service, and you just continue breaking off more and more subgraphs from there until eventually the monolithic GraphQL API has ceased to exist because everything has been redistributed across subgraphs. Okay. So the next question is, does federation help with making it easy to handle namespace collisions across other subgraphs? So with this question, I mean, there's a few different dimensions to this. So in terms of namespace collisions, we can think of two different scenarios, I think, here. So potentially could be a value type or something that's not a value type that perhaps may need to be turned into a value type in the future. So just building off of what I pointed out in the cross-cutting concerns best practice section of the webinar. If you make a change to a value type in one of your subgraphs, and that change hasn't been coordinated across all of the subgraphs that implement that value type, then using managed federation with a schema registry will 100% give you a user interface for realizing what kind of composition errors have occurred and giving you a path forward for how you want to handle those composition errors. So it's going to give you some visibility on that. You're certainly going to get some feedback even without managed federation. As you try to compose your schema with value types that aren't consistent, you'll get some feedback from that as well. For instance, if you're using the Rover CLI. But I think for if you have scenarios where you think that this is going to be an issue, I definitely encourage you to take a look at what managed federation and a schema registry can do for you. Okay, so moving on to the next question. This is a bit of a longer one, so I'm just going to give it a quick read here. Okay, so if both services or subgraphs have a connection to the same database, for example, if in the review service I would query to get product and return it, it would go to the resolve reference in the product subgraph, even if we provide the whole product object. As I understood, the only way to prevent this has something to do with the Provides Directive. Could you elaborate that and give some examples? So yeah, it sounds like app provides is definitely going to be the answer here. So the app provides directive, this is particularly useful actually where you have two different data stores and some of your data has been denormalized across those two different data stores, and you want to save network hops where they might not be necessary because say the review service can actually provide more data about a given product than just its ID. So in that case, you could use the app provides directive to say, hey, my review service knows more about the product than just the key. I want to provide these additional fields if they're queried for, and that can in fact help you save a network hop back over to the product service to get that additional data. Okay. Okay, so the next question is, my team is considering publishing a subset of our API as a product. Does Apollo Federation facilitate configuring and controlling endpoints as public or private? If we aren't using multiple data stores, would using federation to accomplish this be overkill, assuming it's possible at all? So given the amount of context I have in this question, I would say that one thing that you might be interested in that's on our product roadmap is the idea of being able to have different contracts available for your schemas. So depending on who the API consumer is, you may be able to expose different subsets of your schema to them based on some contract that you define. And this is a little bit outside the scope of the schema design best practices content for today, but I would definitely encourage you to sign up for upcoming product update webinars because that will be the best place to get more information about those features as they become available. And that's specifically going to be related to Managed Federation and Apollo Studio where you would implement that. Okay. Let's see. So for our next question here, so the question is, would love to know if there's any examples you've seen or heard of for schema governance at scale at companies. For example, how to ensure subgraphs aren't defining poorly named entity types, single monorepo of schema types that can be PR reviewed and enforced versus multi-schema repos across a company, and how to enforce/review those schemas and PR. So for this, what I would recommend again is go check out that GraphQL at enterprise scale ebook that I mentioned. That's free for download at apollographql.com/guide. Currently it's in PDF format, which you can download there. We'll also be shifting a lot of that content over to our docs as well in the very near future. So stay tuned for that. But in that guide, the most recent chapter is on graph administration. And towards the end of that chapter, there's a section on schema governance where we give you some tips on how you can implement governance practices for your federated data graph. So for that, I definitely encourage you to go take a look at our guide for some detailed information on how you can approach that. Okay, so for our next question, so there's a question here about, will you be sharing the slide deck with us? Is everything being said here already available in a document of some sort? And yes, again, just to reiterate, chapter 4 of the GraphQL Enterprise Scale Guide will cover all of the content that we explored in the webinar today. And then we'll also be sharing a recording of the webinar too, so you can have that as a resource. So we have another question about graph governance here as well, which is who do you recommend owns the governance of the graph schema consistency? So I'm going to give a classic developer answer, which is that it depends. It's going to depend very much on your specific context and your specific organization. So again, in the GraphQL Enterprise Scale Guide that I've mentioned, in that final section of the most recent chapter, we go into governance in detail, and we provide examples of who you might include in your GraphQL governance group that helps guide the direction of your federated schema design as time goes on and how that evolves. So there's a variety of different stakeholders that you may want to involve in that. You're certainly going to want to have representation from people who work closely to your different subgraphs. You're going to want to have representation from a DevOps level, an architectural level. You're also going to want to absolutely include representation from client teams too, because GraphQL is an API that's a way of building APIs that's very much motivated by the spirit of doing so in a way that helps us suit client needs. So we want to have those client needs and those product requirements in mind as we're evolving our schema in the future. So again, I would encourage you to take a look at the GraphQL Enterprise Scale Guide for more specific implementation details on that. But those are just kind of a few quick tips of things that you can think of when structuring your data graph governance group. Okay. So let's see what questions we can answer next here. So we have a question here about whether a schema governance check can be done locally before hitting the pipeline. I'm trying to make sure I'm not adding an already existing attribute name to my subgraph prior to the schema governance check done in a pipeline. So for this, I definitely encourage you to take a look at the Rover CLI. So the Rover CLI can be integrated very nicely into a CI/CD environment, but you can also use that CLI, of course, locally, and you can run checks against your federated data graph as you iterate a subgraph schema to ensure that as you're evolving that schema locally and in development, that's actually going to compose into your schema before you initiate some kind of check throughout a CI/CD process and then attempt to publish that schema. So definitely take a look at the Rover docs for information on how to use that CLI. Let's see, for our next question here. Let's take a look. Okay, so we have a question here about, should common directives be duplicated across all services, or can they be referenced with something like add external? So add external isn't going to come into play here for custom directives. And for custom directives, again, you're going to want to consider the two potential use cases for custom directives, which is whether or not you want to implement a type system directive or a schema directive, or if you want to implement an executable / query directive. So for the type system directives, I mean, you can duplicate them across your services as much as you need to use them within a specific subgraph services schema. And there's no need to duplicate those for a subgraph schema where it doesn't actually need to be used. Query directives or executable directives, on the other hand, are something that you will need to implement consistently across all of your different services. So yeah, I definitely encourage you to take a look at the Apollo Federation or Apollo Gateway docs for specific directions around this. But again, with executable directives, these are things that are going to need to be implemented consistently across all subgraphs. So in that case, that's a requirement. Let's see. All right, so we have a question here that is, what is the best practice for when you need to communicate between two federated services? For instance, service 1 is dependent on service 2. Do we query service 2 by federation or directly to the service? So we are in the middle of refactoring a monolith into federated schemas. However, we still have dependencies between these services. So could definitely some additional context I think would help focus the answer to this question, but I think I can answer it in two generalized ways. So the first is I think it would depend on the nature of what you're querying. So query planning with federation can definitely help coordinate taking different responses from your different subgraph services, and then of course aggregating those back together at the gateway level and then sending them back to the client that requested that data as a cohesive response. So in those instances, there's no need for needing to do any kind of manual querying of your multiple services and then putting those pieces back together to send back to your client. Another direction that you could potentially interpret this question, I think, is when you're handling something kind of like along the lines of like a distributed transaction. So where something happens in one service, and then in response to that thing happening, you need something else to happen in some other service. So here I would say the same rules apply as you typically would for any as you would typically apply for any microservice architecture. So in those instances, you need to make a decision. I've seen this go both ways, where I have seen one service actually using a GraphQL client to run a mutation against another service, and doing this like more or less on a one-off basis. Like if this is something that becomes like a common pattern within your graph, I think you're going to want to explore other architectural options. And that other architectural option that I often see is that you end up embracing more of an event-driven architecture, and you look at using sagas to coordinate communication between your different services. And rather than pulling that down to the GraphQL level, that's something you lift out a little bit higher, and you use some kind of event-driven system to help support that kind of inter-service communication. So again, the same rules that you would typically apply to any kind of microservice architecture in relation to inter-service communication are almost certainly going to apply when you're dealing with federation as well. Okay. So we have a question here. Does Apollo Studio work with non-managed federation? And to answer that question, I think it's going to depend what exactly you want to do with Apollo Studio. So if you want to use the schema registry and the tracing features that are built into Apollo Studio, you're definitely going to be using managed federation for that, because you're going to be registering your schema with Apollo Studio. That's part of what the managed portion of managed federation is. But if you want to use features of Apollo Studio, such as the Apollo Studio Explorer, as an alternative to using other GraphQL GUIs such as GraphQL Playground, then you don't need to use managed federation for that. You can very easily hook that up to a data graph that's running in your local development environment and use that feature as a development graph rather than a deployed graph. Okay, so we have tons of questions here. We only have a few minutes left. I'm going to do my best to get through as many as possible in the few minutes that we have remaining. And then again, I definitely encourage you to head over to community.apollographql.com where you can post any other additional questions that you may have. So we have a question here. In the earlier example, how is product data resolved under the review entity? So is the resolver implemented in the review subgraph or the product subgraph? And the answer to that question is both. So in the context of your review service, it needs to be able to return something from product resolver. And that product resolver is really, it's just going to be a representation of that entity. So it'll be the type name and then the corresponding type name product in this case is the value. And it's also any key data that you need to include. So in the product example, you'd include the UPC field, which presumably the review service has access to, as well as that value. And that is what you ultimately return in that resolver. Send that data to the gateway, and then the gateway is going to handle actually resolving the full products as needed for that query. It's going to be on the products service to fill in all of the additional details that may be needed for a given product to resolve that query. And to do that, you're going to use what's known as a reference resolver. So that's how the pieces work at a high level. I definitely encourage you to take a look at the Apollo Federation docs for more information on exactly how all of those different pieces fit together. But at the end of the day, you're just writing a couple basic resolvers in the reviews service and the product service. And you just want to make sure that you're implementing that reference resolver in the product service to resolve any entities queries that are sent its way. Okay. Let's see. What other question can we cover off before we wrap up? I think we've got time for one more. So here's a really good one. Are the @key and @external specific directives from Apollo, or is it part of the specs? So in case Apollo Federation is non-standard, how are you planning coverage? How are you planning to converge with the GraphQL working group? So this is a really great question because when you're looking at implementing Apollo Federation, and you have your subgraph schema, and we saw snippets of what a subgraph schema may look like with the @key and @external directives added to it. You're going to need definitions of those directives somewhere in your schema. So if you're using Apollo Server as your subgraph, the Apollo Federation library exposes a build federated schema function, which you can use to wrap your type defs and your resolvers that you designed for that schema. And that's automatically going to apply all of the federation specific decorations you need to add to your schema per the Apollo Federation spec, which is listed in our documentation. If you're not using Apollo Server as your subgraph GraphQL server, that's fine because the Federation spec is open. So GraphQL servers can add support for Apollo Federation as well by implementing the Apollo Federation spec. So basically that necessitates that if you want to use that alternative GraphQL server as your subgraph and have access to things such as entities to interact with within that schema, then that GraphQL server can implement that Apollo Federation spec by adding those necessary directives, and there's some types that need to be added, as well as a couple of fields on the root query type. And that will give you support in the subgraph for it being composed into the broader federated data graph, and also having support for responding to entity queries and things of that nature. Okay, so there are still tons of questions in here. I really appreciate everyone showing up for today's webinar and being so engaged and in providing so many amazing questions for us. I wish I could have had time to answer them all. I think we could have spent a full 2 hours on just the questions alone. But as I mentioned, the Apollo forums are a great place to post these questions. You can also find me on Twitter at Mandi Wise, and I'd be happy to engage there as well. And again, I'd just like to say thank you so much for joining us today for this webinar. And you can look forward to receiving a copy of the recording in your inbox shortly. So thank you so much, everyone, and have a great day.